Alright, so in part C, we're told to consider a new point D such that this D will have a vector of W in between A and D. And we're told that U dot V is 0 and V dot W is also 0. And the area of triangle ACD is 5. We need to find the vectors for W. So what we need to imagine here is that we have the 2D plane with the first triangle, and we have a new vector that is perpendicular to both vectors. So we can kind of imagine this 3D coordinate system where X is to the right, Y is like upwards, and Z is kind of also upwards, but out of the page as well. So I kind of try to draw it in 3D here so that we can imagine that this W is perpendicular to this one and to this vector here. So this ADC kind of comes out of the page here. And we need to find the value of this W. So what we can do is from the previous part, we have solved for P is equal to 1, so we can find the value of vector U. So this will simply be 1, 1, 1. If we plug into that formula we found in the previous part, and V will be 3, 1, minus 1. So what we know is that W is going to be perpendicular to both of these. So let's just say that W for now has some coordinates x, y, z. They're unknown, so let's just say x, y, z. So let's write down what the dot products are. So U dot W, that will simply be x plus y plus z is equal to 0. We can also write down V dot W, that will be 3x plus y minus z is equal to 0. So what we can do now is we'll add these two equations so that we eliminate the variable z, because now it will be going into some algebra solving equations. So we need to solve for x, y, and z. So if we add these two, we'll get 4x plus 2y is equal to 0. And so what we can say is that y is equal to minus 2x, right? We just rearrange the equation. And what we can also say is that, for example, from this equation, z is equal to minus x minus y. So we can plug it, we know what y is now, minus 2x. So it will be minus x plus 2x, so this is just equal to x. So z is equal to x. So we can kind of write down the coordinates of w in terms of x only now. So that is a lot better. So the x coordinate is simply x, the y coordinate is minus 2x, z coordinate is x. So we can factor out an x if we want, so this will just be 1, minus 2, and 1. Alright, well now we need some other equation we can use to actually find the value of x, which is that we can use is that the area is 5. So we know the area will simply be 1/2 of the magnitude of the cross product of two of the vectors of the triangle. And well, we know v and w here, so we know v is 3, 1, minus 1, and w is this x times 1 minus 2, 1. All right, so let's find the dot product. I mean the cross product. So if we do that, well, there's several ways you can do this. There's this formula in the data booklet that, I mean, you could use, but it's not the most efficient way to use to do a cross product. So what I like to do is just the x we can just factor out, and we need to do v cross w. So these are the two vectors we should be looking at here. So the first component we can find by not looking at these two and finding the determinant of these two terms over here. So it will be 1 times 1 is 1, and then minus 1 times minus 2. So that will be 1 minus 2, so that's minus 1. The middle term we can also find by not looking at these two and then finding the determinant of the remaining 2 by 2 matrix. So that will be 3 minus minus 1, so that's 4. But in the middle term, we need to put an extra minus. That will be minus 4. Then the last term, again, we can just remove these two. That will be 3 times minus 2 is minus 6, and a minus 1 is minus 7. So we have found this. Now we need to find the magnitude of this vector. Okay, so magnitude of v cross w. This will simply be x times square root of 1 plus 16 That's 17 plus 7, that's 14 plus 49, so that will be root 66. And we know that this has to be, well, 10 if we just take this 2 to the other side. This is equal to 10. So we can solve for x. And so we find that x is 1.23, and we just multiply over here to find the coordinates of w. Like this should be a minus, obviously. This is 1.23. All right, so that is how you solve this last question.